All right, we're going to talk a little bit about even and odd functions. Okay. Um, let's talk about what they are, and then we'll kind of get into why they're called even and odd and why we care. Okay. So, an even function, this is the mathematical definition, f of negative x equals f of x. Now, this is a really fancy way of saying that if we change the sign on the input, it doesn't change the output from your regular f of x. Okay, so um, for example, x squared is the exact same as negative x squared, okay, or negative x squared, because when we do that squaring, it completely negates that negative. So this negative x squared is the same as if we just had the original. Um, and the reason that they call it even is because these um, functions like x squared, x to the fourth, x to the sixth, all of these have this even property. Um, now, these aren't the only functions that show that. You'll see some other ones that do that. You can see it visually by y-axis symmetry. So that the same number over here when x is positive is the same number over here when x is negative. Okay, so that's kind of the visual representation of it doesn't matter whether it's positive or negative. Um, so here's x squared, here's x to the fourth. You see that same symmetry. If I change this to x to the sixth, you're still good to go. Um, Also, absolute value. Okay, obviously, it doesn't matter whether you put the positive value or the negative value in there, you're going to get the same output. Um, we won't use this in this class, but the cosine function, you'll see it's symmetrical. Um, and one of the reasons that this is useful, this knowing whether a function is even or odd or none of the above, is if someone tries to throw in, cosine negative 6x, and you're sitting there going, "Oh, I don't know what to do with that negative." Well, you can literally just delete it, and it doesn't do anything because the cosine function is um, an even function. Something else I want you to notice. The constant function, like y equals 5 or y equals 7, it's symmetrical because it doesn't matter what sign your input is, because it's always going to give you the same value. It's always going to give you 5. Another way of thinking of this is x to the 0, and the 0 is even. Okay, but it's very important to remember that the constant function is even. Also, if you have a function that every single term consists of an even function, then the entire function will be even. So this is, maybe kind of a weird function going on here, but you'll notice it is still symmetrical over that axis. Or, if I did negative 2x squared plus 8, it looks weird, but it's still symmetrical, and it still doesn't matter what sign you put in. It's going to give you the same value whether you're giving the positive x value or the negative x value. Now let's talk about odd functions. Now, odd functions, it's basically the opposite. Whatever sign, or if you change the sign on the input, you'll get the identical output with the sign changed. Okay, the value multiplied by -1. Okay, so changing the sign only changes the sign of the output. Okay. Um, so for example here, if I plug in positive 5, I get 5. If I plug in -5, I get -5. Or here, if I plug in 2, I get 8. If I plug in -2, I get -8. Okay, so changing the sign of the input All it does is it changes the sign of the output. It doesn't give me a completely different output. It just changes the sign. Now, how can we see this visually? Well, we can see this visually because it has 180-degree rotational symmetry about the origin. Now, that sounds super fancy, but literally what it means is if you turn the graph upside down, it will look exactly the same. So I've flipped my laptop upside down, you can't tell, but my graph looks completely the same. If you had a sheet of paper, same deal. If you take the paper and you go, if your graph looks exactly the same, then that means that you have 180-degree rotational symmetry about the origin. Okay. Um, if you turn it upside down, it should look the same. The reason it's called odd, again, look at all of these odd powers of x. They all have this property where if I rotated them 180 degrees, it would look identical. Keep in mind, the constant function is not odd. Okay, it's even, so it's not going to have that property. Another function, the sine function, is odd. You can rotate it 180 degrees. And again, one of the reasons this is useful is if I shove this in, and you're sitting there going, "Oh, I don't want to deal with sine of negative x." Well, you can move that negative outside. That's going to give us the exact same value as if that negative was inside on the input. It might make our math a little easier to deal with. Okay. So we could have a expression here. I don't know. X plus 5x to the 5x to the third minus 7. We'll do 4x to the fifth. Keep in mind, this is an even coefficient. The coefficient part doesn't matter, doesn't affect whether it's even or odd. But this is odd, this is odd, this is odd. So the sum of those will also be odd. So if we look at our graph here, you'll notice if I rotated that 180, it would still look the same. Okay, so the sum is also an odd function. Now you can also have functions that are neither. Most of the ones that I show you that'll be neither is something where you've got an odd term and an even term. Remember, the constant function is even, and this linear one is odd. So if I add them together, you get something that doesn't have either property. So if I change the sign, it will change, but not just to the negative value. Same thing here. I've got an even and an odd. It's not symmetrical. It doesn't have rotational symmetry. So it's going to have neither of these nice little properties. I also wanted to show you just one that just doesn't have either property. This 2 to the x doesn't have that rotational symmetry. It doesn't have the symmetry across the y-axis. It's neither even nor odd. So you can tell by trying some inputs. You can try it by looking at the graph. There's a lot of ways you can determine whether it's even or odd. But there you go. There's a summary of even and odd.